Hello, my name is Michelle Gayan, and today in this video I am going to explain about simple curve fitting by offset tangent method. A curve fitting survey is required for fitting curves along roads and railway lines while changing the direction. Curves are provided at the intersection of roads and railway lines for a smooth ride. It is also required for fitting curves along dams, reservoirs, and in buildings as per design and plan. There are two types of offset tangent method to fit curves. First one is radial method. It is used when center of curve is visible from points on tangent. Second method is perpendicular method. It is used when center of curve is not visible from points on tangent. The aim of this experiment is to fit a curve using both perpendicular and radial offset tangential method. The materials required are chains, cross staff, pegs, arrows, and ranging rods. First, I am going to explain about perpendicular offset tangent method. First, a length AB is taken and another length BC is drawn from the length AB at any angle called deflection angle such that AB and BC intersect at B. Perpendicular offsets are drawn from both AB and BC at equal intervals. The length of intervals should be small to get a smooth or accurate curve. Large intervals will make a rough curve. The point from which the first offset starts is called the tangent point since AB is tangential to the point. One of the tangential points of length AB and BC is the start of curve and another is the end of the curve. The length of tangent is given by the formula r into tan of half of angle of deflection. We calculate the tangent length with this formula. The length of offsets are given by the formula O x square is equals to r minus root over of r square minus x square, where x is from 0 to n. N is the total number of offsets on one side of or on one length. This is for getting the accurate value of offset length. The formula Ox is equals to x square by 2r can be also used, but it gives approximate value of offset length. R is the radius of the curve. The length of exit offset of AB is equal to exit offset of BC. Since if we divide the curve by a length drawn from B, both the sides are symmetrical. After measuring length of each offset, we get points x1, x2 till xn on AB side and y1, y2 and till yn on the BC side on the offsets, which are ends of the offset away from the tangents. We join these points to get the curve. Next, I am going to explain about radial offset tangent method. A length AB is taken and another length BC is taken, drawn from the length AB at any angle called deflection angle such that AB and BC intersect at B. Offsets are drawn from both AB and BC at equal intervals such that the offsets meet at the center of the curve. Similarly, in this method also, the length of intervals should be small to get a accurate curve. Large intervals will make the curve rough. The point from which the first offset starts is called the tangent point since A is tangential to the point. One of the tangent points of length AB and BC is the start of curve and another is the end of curve. Similarly, the length of tangent is given by the formula r into tan of half of angle of deflection. We calculate the tangent length by this formula. The length of offsets are given by the formula OX is equals to r root over of r square plus x square minus r, where x is from 0 to n. As we know, n is the total number of offsets on one side or on one length. This formula is for getting the accurate value of offset length. The formula OX is equals to x square divided by 2r square given gives the approximate value of the other of the offset length. We know the length of exit offset at AB is equal to exit offset of BC. Since if we divide the curve by a length drawn from B, both the sides are symmetrical. After measuring length of each offset, we get points x1, x2 till xn on AB side and y1, y2 till yn on the BC side, on the offsets which are ends of the offset away from the tangents. We join these points to get the curve. Now the length measurement of offsets and tangents can be done by chain surveying. In perpendicular offset method, perpendicular offsets are made using cross staffs.